Hey, what's going on, guys? Komakikins here. Finally, in this video we're gonna create the square attack function, which serves the purpose of telling whether a current given square is attacked by some sort of a piece on the chessboard or not. So last video we ended up with setting up the piece move offsets right over in here that we will make big use of in this video in particular, and also we create the function called print attack maps, or I don't really remember how exactly I did call that function there, so let me just try to find that. Yeah, print attack squares. And also we did just define this square attacked function, so from now on we'll actually start populating this square attack function with some sort of a code. So I just want to open the terminal in the current working directory, and by typing make, so I did create a make file in the previous part, and if it compiles then I just want to run the program, just hit enter, and it prints the board containing only the white knight here, and also it prints kind of attack map, so nothing is being attacked at the moment because the square attack function is not yet being created. So I just want to here, well, let's start with, I don't know, with white pieces 4. So I just want to put some pawns on the board. Well, let's have them here. So 3 pawn 4, and I also want to have pawns at the board edge from here, and well, let's say here as well. So this would allow us to distinguish between the pawns that have 2 options to attack, and also those pawns that are actually kind of not those pawns that can attack only to the one side, so to make sure it won't be shifted, so the offset won't be shifted to some weird place on the board. Well, okay, so let's actually start here. So our square attack function would be returning either 1 if square is attacked, or 0 if it's not, basically. So here I can say like pawn attacks, so let's say yeah, let's just say call this pawn attacks, and the pawn code, the code to distinguish the attacks by the pawns would be slightly different compared to the other pieces. So here I can say just if well, let's, so where do we starting with? So we have this white pieces, right? So now we're trying to, so we have white pawns, right? So this means that is square attack by white, yeah, and this would give us side equals to white here, so the side is equal to white. Well, so I can say if the side so one more little thing, so the side the white is equal to 0, I guess, right? And the black should be equal to 2. Yeah, white is 0 and black is 2. So to make sure that it is attacked by the white, I need to say if not side, which means that which is equal, like if I would say if side is equal to 0, but just the shortcut to say like if not side. Well, let me just try to compile around this to make sure it still kind of works and I didn't break anything. Okay, and now if, so the very first thing to consider, I want to make sure that the square that we're supposed to be moving our pawn to lies on board. So how to figure that out? So if you've been watching the previous video, you remember that when we're talking about the offsets, I said the offsets for the bishops and for the pawns are the same. So let me just try to recall my memory regarding the NDNS of our board array. So we start, so A8 starts here. So white pawns would be attacking to, so this, so the attack square would be less than, well, I would rather better just to use this trial and error method. It would be really faster. So let's try to say like square we'll use the 15 and 17 offsets and minus 15 and minus 17 respectively. So if we just run a bitwise AND this stuff with the hexadecimal 88, and we say if all this stuff is equal to 0 or if it's kind of not. So in this case we make sure that, so this expression allows us to make sure that the pawn is actually on board, that the target square is actually on board. And here I can say and now I say like board indexed by square minus 17 equals to white pawn, right? Okay, so in this case I guess we want to return true, right? Okay guys, just return once. Just hold on a second, I need to figure out one little thing here. Yeah, it seems to be just fine. So let's compile and run the code again. Okay, what's run? Okay, not the SQ but square, and square here. Yeah, because we call this a square variable. Okay, so here are our attacks. Well, slightly bit not really what I expected there. Okay, so I put too many pawns at the moment, so let's just get rid of this pawns for a while. I just want to figure out the direction. So well, it seems like, so it's rank 4 and here rank 3. Yeah, it seems like this pawn is actually trying to bit backwards while this is not true, so pawns are going forwards. So this means that I need to say here like plus 17 and here like plus 17 like this. And we have the only direction just to the right. Also we need the direction to the left, so I just copy this and paste, and using this plus 15 index, save. Okay, and yeah, so now we got the pawn on d4 right over in here, and it hits the squares like c5 and e5, which is good. And yeah, now we can add a couple more pawns to make sure that actually they are not capturing off board. So pawn and 7 and well, let's say 7 and pawn, 7 empty squares followed by the pawn. Okay, so we got this pawn on a6 which hits to b7. This is okay, so we have this d4 pawn attacking 2 squares, and we have 1 square g4 attacked by our g pawn, which is good. Okay, perfect. So now let's try to make this pawns black, and just make it black like this, and like this. And now it shouldn't print anything. Yeah, and now we will just say else, and here I grab the code, copy and paste the code, and just switch this pluses to minuses, and this should be literally enough. So this pawns would be capturing from top to bottom. Okay. Okay, what's going wrong? Oh yeah, that's because we need to match this black pawns instead. Okay, so I'm a little bit wondering why it doesn't work. Oh no, this is the big one, right? The big pawn, the big one, and here we got a little one. So P, this is the black pawn. Oh, that's happening because I didn't change the side yet, so I need to change the side to the black pieces. You know, like probably I can say this like this, so I can say printf and just attacking side to specify that as well, and this would be string, right? And we say, so if side so if not side, then we can print like white, otherwise we can print black. Okay, so attacking side black. Okay, just give another new line here. Okay, why the new line is not working? Okay, so here we got this attacking side black. Okay, maybe I just need to switch this slightly. Yeah, I like this better. And also I want us to put the second one, well, probably, well, yeah, let's not do this. So just like this. And now we got this attacking side white. So again, like attacking side black, and we should have, so let's check this out. So we have the pawn on d4, so c3 and e3 are attacked, perfect. Also b5 and g2, so b5 is attacked, the g2 is being attacked as well. Yeah, this is quite pretty nice. So it seems like our pawn attacks are done here. So, well, I guess we can move to other pieces. So the next thing to generate attacks for would be the knights. So let's define our knight attacks here, and this is gonna be slightly bit easier compared to these pawns, because here we can loop over the knight move of sets. So let's say for int, how to call this, well, let's call this index equals to 0, index is less than 8, because we have up to 8 elements within the knight offset, within the knight offset attacks, and index plus plus. So here okay, let's first try to print our index, just to have a look at them one more time. So D and this like undeclared. Oh really? How is this possible? Error index undeclared. Whoa, this is interesting. So probably I'm already a little bit tired. So I've just defined this index variable. What can get wrong here? Well, is this file right? Okay. Oh my god, what am I doing wrong? Just hold on a sec, guys. Well, okay, it looks completely weird, so I would try try again, basically. So for int index equals to 0, okay, index less than 8, and index plus plus so can we reference our index? Oh, thank God we can. I have no idea what kind of was run there. Probably some sort of a typo. I have no idea. Okay, so let's try to print f our index, and we want this decimal here. Okay, so we got our night indexes. Yeah, they are printed a little bit too much, I guess. Like, hold on a sec. What is this? Oh, it's been printed along. Yeah, it's a bad idea to print the index this like way. So I'm just wondering how to make it better. Well, just forget this basically. So here we need to define a couple of variables. So first we need to define the target square that is potentially can potentially be occupied by the knight, and also the piece within that target square. So let's calculate target square, and let's say int target square would it be equal to actually current square plus knight. I'm referencing this knight offsets. Is this called knight offsets? Array that is responsible for the knight moves. Okay, knight offsets, right. So I'm referencing this knight offsets, and by the index. Now we need to define calculate well, not calculate, it's better to say like lookup, or here we'll say init target square, and here we say lookup target piece, and int target piece would it be equal to actually board indexed by the target square. Okay guys, sorry, just been distracted by a phone call. So square like this, and now we need to make sure if the target square is actually on the board. So how to call this? So square is on board. How did I command that stuff? Yeah, if square is on board. Yeah, let's skip it basically. So if target square is on board, so to know if it is so or not, we can say if, and then we just bitwise end our target square and the hexadecimal 88. You see, like this hexadecimal 88 allows a one-line solution to answer this entire question, like if the square is on board or off board, which is absolutely stunning, basically. So I really like this, and if it is actually, then we need to return, and Okay, hold on a sec. We also need to match the piece. So just hold on, guys. Okay, so match the side now. So if and not side, which means white. So if it is the side is white and the target piece is equal to so if it's white, it should be equal to white knight. Otherwise okay, just hold on a sec, guys. Yeah, everything is right. So, and here target square, target piece equals to black knight. Okay. In this case, we want to return true. So we'll now start debugging this. So let's go slightly into this expression. So if the side is equal to 0, which stands for the white pieces, in this case we returned here we returned the evaluation of this expression. So target piece is equal to knight. So if it is true, then this entire is true. Otherwise we evaluate this expression for, so if the side is black, we'll evaluate this expression. So if the side is white, if returns so this condition either true or false. So if it's true, we return 1, and for the black pieces, if this condition is true, then we return 1. But this is all is just in theory for a while, so I just want to make sure this while testing. And also let me just provide, so do I need really provide some commentaries here? I guess I should have. So if target square is on board and is white pawn, okay, copy and paste in here the same, but and it's a black pawn, right? Okay, and now let's switch our side to white again, and I want to get rid of these pawns for a while, so try to get rid of them and replace this with a white knight. And if I did everything correctly, this should give me the attack squares, yeah, but the white knight exactly. So I guess if I just switch this to black, it shouldn't give me anything. Yeah, assuming that the white knight is on the board. Okay, so it's kind of white, perfect. So now let's try to move the white, move the knight slightly a bit. So let's put this to the counter. So let's give a couple of squares, and then the white knight, and then 3 and then 5 squares, I guess. Should it be? Okay. So where is our knight? So 2 squares, then the knight. Yeah, seems to be. So okay, let's let me just try to put the knights into the corners to make it absolutely sure. So knight and 7 here, 7 and the knight. Okay. So hold on a sec, where did I? Oh, it's a bit, no, not here, sorry. So 6 and the knight here. This would be right. Yeah, so knight here, knight over in here. Okay, and just put a couple of knights to A1 and H1. So N6 squares and knight. Yeah, perfect. So a knight in the counter. Yeah, so get up to 2 squares attacked each one. Okay, this is pretty nice. And now let's do the same for the black knights. So 3, the black knight, 4, and save, and just try to switch the side to the black. Okay, and now let's try to put this into here. So knight 6, knight, save. Okay, and knight 6, 9, knight. Okay, so it seems like it's working quite pretty nicely. Well, okay, this is already good, thin. So the next leaper piece we're supposed to be generating attacks for would be the king. So let's say 3, and let's consider the white king, and 4. Save, and nothing is generated because we didn't yet kind of take care of it. So this loop would be exactly the same unless we'll use king of sets instead of knight of sets. King of sets, and here we'll use we'll match not the knight but the king, and not the little knight, not the black knight, but the black king instead. Okay. I'm sorry. So what did I do wrong? King offsets. This should work. Okay, do we have a king on board? Yes, we do have the king. Oh, that's because we need to switch to the white pieces, obviously. But hold on a sec. Yeah, that's because we have white pieces. Yeah, right. So here is our king. Oh my god, I don't really need the browser. Sorry, guys. So yeah, and now let's try to put the king into the corner as well. So king. Well, it's not a valid position, but still I can say like king 6, king, and king 6, king. It's not a valid chess position, but oh, but just no. I want this big kings here, so white kings instead of black ones. Okay, yeah. So we got this square being occupied by the white kings, and the same for the black kings. And we just need to switch the color to black. Save, and the same result. Yeah, perfect. So yeah, we did have this black kings. Okay, and let's just try to put this king randomly to the center. I don't know, like 2, king, and 5. Okay, so king on c6, and these are the squares occupied by the king. Okay, this is pretty nice. This is pretty nice already. Okay, so what else to consider here? So the next pieces to take care of would be the sliders, and generating moves for the sliders is a little bit more tricky and complicated compared to generating moves for leapers, but the idea is literally the same. So in order to generate attacks for sliders, we need almost the same but slightly bit different. So I just get rid of all this stuff for a while, and here I need to have an additional loop. So loop over the ray, over the given attack ray. So let's call this attack ray. So we can say while, and so here we did match the single square. So asking like target square, bitwise ended with the hexadecimal 88. So we did search for the only square, and here we're searching for this within the loop, and every time we want to say that the target square would be equal, like plus equals, so target square equals target square plus and this offset, oh, not the target square but the target piece actually. Hold on, yeah, sure, not the target square but target piece. Oh my god, sorry guys, just hold on. My god, I actually did want to make this correctly for the first time. So plus equals, well, not the king offsets, but here we have, by the way, the bishop offsets. Okay, and so again, plus equals bishop offsets. Sorry, what have I done? What have I done? Yeah, like this. So here we increment target square. You can call this like this, I believe. Increment this target square by move offset. Yeah, seems like. And now let's specify the target piece. That would be something like the same. So int target piece. Target piece would be equal to board indexed by sorry, not the target piece. What have I done? Target square indexed by the target square. Okay, and another important condition here. I need to say so break if hit a piece. So for Lippers, we could it didn't really matter that much whether the attack square does contain some sort of a piece or doesn't. So the only thing that did matter is actually whether the target square is on board or not. Well, if we loop in within, so let me just, probably it would be better to show you this within the Lichess, just to make it slightly bit more clear to understand. So, and sorry, what have I done? Analysis board. Yeah. So, you know, like, yeah. Let me just try to make some moves, some weird moves. So here, you see, like, if we trying to calculate the attacks by bishop, if we ignore something on the board, we will go until we get off board, basically, right? So we really need to break this loop when we hit something. Well, now I'm explaining this from the move generation perspective, but in case of, let's say like we stand right over in here and we iterating right over in here. So if we have something on board, then we have to break this loop. So just to make it a little bit more clear. Okay, probably oh, maybe just leave this Lichess for a while. Okay, and what else? So break if hit a piece. So I can say if board yeah, so if just hold on, guys. Yeah, it's all correct. So I can say if our target piece is not equal to 0, or otherwise probably so this is just more readable way. So in this case we just break, but I guess we can say just if it's true. So anyway, this would be like if it's not equal to 0. So in this case we want to break. And now the logic of defining the if there is a piece actually. So how did I call this? So yeah, I didn't yet provide the commentary here. So if target square, if target piece is either white or black king, and copy. Yeah, but one little more thing here. So we're here. We're not only looping over the index of bishops, but at the same time this indexes regards to queen as well. So let's say bishop and queen attacks. Okay. Okay. White or black, bishop or queen. Okay, so if now we need to use this not side trick, so not side, so if this is white, or hold on a sec, yeah, so target piece is equal to bishop, or target piece is equal to queen. Okay, so I just want to enclose this within the parenthesis, and otherwise this would be black queen and black bishop, and yeah, in this case we want to return true. Okay, yeah, this line is a little bit too long, but yeah, I guess this is just fine. So let's try to check if this kind of works. And so we did both, right? White and black pieces should work. So let's consider white pieces, and let's consider white bishop. Okay, so it now should draw or render some attack race. It gives me an error instead, so seems I dropped the semicolon somewhere along the way. Let's see where. Okay, this within this break. What? Before if, comma expected. Okay, maybe this like. Yeah, perfect. So you see, like, now we got this attack race for the bishops. So let's try to put this bishop slightly bit to the center. So let's put this like 3 bishop and 4 this like. So we got this bishop almost in the center, and if we set a pawn, well, let's consider some black pawn on well, let's consider this here like f4, so it's rank number it's 1 to 3rd from the right side, and 1 to, so here, and we need to have like 1 2 3 4, no, here like 1 2 3 4 5, and then the black pawn, and then 2, right? Save. Okay, you see, like, this square is not attacked by the bishop because a pawn stands here, and this square is not attacked by the bishop again by this bishop because pawn is protecting this from getting attacked. So that's the reason of using this where is this, my god, if target piece, well, and if I say like is not equal to 0, this should give me literally the same result, right? So just a short card like this. Okay, so, and literally the same should be equal for white queen. Save. So the same attacks for a queen, because we match the queen along with the bishop. Here we match not only the bishop but the queen as well, or same for black pieces. Okay, so now, oh my god, now let's go and try to convert these guys to small, to kind of switch the colors. So black bishop and white pawn, and here respectively we want to generate attacks for black pieces. Okay, so it's really the same result. Okay, perfect. And we just make it a queen. It should be the same. Okay, but hold on a sec. I'm just wondering. It also generates. Hold on, guys. Something has gone horribly wrong. Why does it generate like all the queen moves? It should generate only diagonals. It doesn't have to. So which kind of? Maybe I use the bishop offsets. So something is wrong with the bishop offsets. I'm really sorry for this. What? No, the bishop offset seems to be quite pretty nice. Now what's wrong there? Bishop offsets. And just hold on. How could I not seen this? The light is not bothering you. Sorry, just it's kind of evening out there already. Oh my god, I'm just really wondering how this is possible. Oh, that's because, so now this should work, but I'm just wondering why on earth did this. Oh, that's because the next okay guys, so this is really tricky thing here. I will now explain you. So a C programming language challenge. So if we had here, we did have this kind of 8, and guess where did the loop brought us to? So it stopped here, and then it went right over here for the rook offsets, believe it or not. So that's how the C programming language works. So in the random access memory, these guys are just going one followed by another. So this sort of weird things are quite pretty common cases in C programming language. So just to bear that in mind. Yeah, obviously now it kind of works. So it should be the same for the white pieces. I just want to check if I put the queen and 6, and let's say the bishop here, and here let's say bishop 6 and queen, save and run. What the hell is going on? Okay, this line should not get attacked. Oh, I just yeah, just drop them back to 4. Just drop them back to 4. What? Oh, sorry, what have I done? What have I done? Yeah, here. Drop back to 4. Yeah, so now we get this attack line by yeah, so this is not attacked because of the pawn, and this is attacked because of this. Yeah, this is right. Yeah, it seems to be just pretty nice. Okay guys, so I guess the very last thing for this video left is actually to generate moves for rooks and queens this time. So what I need to do, I literally grab this entire source code and paste this in, and here I say rook and queen, and I need to change this to rook offsets. Okay, and now we match the rook or the queen, and here we match the rook or the queen, and here again like the rook offsets. So I think this should be just right. Yeah, now this is quite pretty fine because the queen really goes this like. So I just want to get rid of the bishops now and just try to try this queens instead. 7 save. Okay, so we got this queen race. So here, yeah, cool. And let's try just to put it somewhere in the center. Well, maybe not here. Obviously, it's not the way how to check that if square attack function works properly. There is a brutal way of testing this called perf testing, which stands for the performance test, and that's absolutely fantastic stuff to consider. And this not only checks the if square attack function, but the mode generator entirely as well. And this is the most intriguing and the most challenging part while you're writing your own chess engine, just trying to pass that sort of a perf test. Okay, so let's have a look how the attacks for the queen kind of look like here. Well, it seems like they're quite pretty reasonable. And one last thing I want to consider, just want to convert this to the white queen and go for the white pieces. Save. Okay, so still generate stuff. And now I just want to make it a rook to make sure that, okay, that rook works. And now the black rook and the black pieces, and it also works. Okay, so I'm not going to be putting these rooks to the corners. I really hope this should work. Well, maybe I can try, but yeah, rook 7. Yeah, so it seems like it's working quite pretty nicely. Yeah, it seems like. So let me just try to figure this out, if this is really it for just regarding this square attack function. So we did cover the pawn attacks, okay, knight attacks, the not knight here, we already have the king attacks, so king attacks, and bishop and queen attacks, and rook and queen attacks. Okay, yeah, this seems to be just perfect. So rook queen, okay, bishop queen, okay, sides seems to be matching, king, knight, and black pawns and the white pawns. Yeah, it seems like. Well, anyway, if any bugs are about to appear in this sort of a square attack function, we'll definitely know about this. And again, like, you know guys, it's much more challenging and intriguing to write the chess engine from scratch, even though I do reference the source code that I've written before, just conceptually, basically, not to miss some important key points. But the particular implementation is really different, and that's the exact thing that makes it really interesting, challenging, and intriguing. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.